it's time to see how we can control the resources over the processes we have in our system. Ubuntu has adopted SystemD, a way of controlling and creating services, and it uses cgroups for this. We can go to directory sys, then fs, and then into cgroup. It's interesting that inside of this directory, all the files are created dynamically. This means that the moment we are starting service, certain settings are created here and afterwards they'll disappear. We see here different directories, the CPU, the memory, and the I/O controlling the block devices. So these are the main controllers. If we go to, for example, CPU, and see what's inside, we see that we have system slice and user slice and also a lot of settings which we can control by typing information inside of those files. The system uses slices in order to separate and control common resources. For the user tasks, we are using user slice. For system tasks such as running services, we are using system slice, and we're using machine slice for virtual resources such as running virtual machines. We can also see the current slices we have, which are managed by SystemD. So we can just type SystemD, cgtop, and we see the user slices and the system slices here. How many tasks are running into those services which belong to the system slice, how much CPU they occupy, as well as the memory. If we go to user slice, here we see common properties which can control the CPU of all the users, and we can get more granular if we go to user 1000 slice, and this is our user ID which we can obtain from etc password. Here we can easily see that on this computer we have user ID of 1000. Okay, so if we go to user 1000 slice, we see the same parameters as the previous directory. Actually, we can modify those parameters to see them in action. For example, we would like to see what's inside of the quota of the CPU, and we can type cat CPU CFS quota US, and we see this number here. Basically, we can use 100% of our CPU. How we can change this quota? For this, we'll use the system control utility. So we will type system control set property. And then for the slice, we would like to target, which is user 1000 slice. And now we will set up CPU quota, and it will be on, let's say, 50%. Okay, now we type our password, and this will set the quota for this user to have hard limit of 50%. So the moment we are running a program which uses 100% of our CPU, it will be limited to 50%. Let's see this in action. So we'll use the stress command. If you haven't installed it, you can type sudo apt install stress. I have it here in the system, so we'll type stress, and we would like to load up 3 CPUs. So we'll pass 3. This will start running the stress command. Let's open another terminal, and here just type the top command. Now we'll click on the button 1, and we see that we don't receive more than 50% usage of our CPU. So that's how we limit the usage of the CPU. Here is the stress command running. If we go back, stop the program, and return to system control by providing 101%, effectively enabling unlimited quota. If we now run the stress, when we go back to the top, we will see that the stress utility grab as much as possible from the CPU, or it's filling it up to 100%. Alright, we can also set not only a hard limit of 50% of the maximum CPU usage. Out of those 50%, a single program cannot have, for example, more than 25%. So we can modify this by providing the parameter CPU shares, and the maximum is 1024. So if we want to use only 25%, we'll type here 256. All right. If we now run stress test and go to the top command, we can see that the stress test is not taking more than 10%, which is 25% out of 50. Okay, we saw how to modify the quota for the CPU controller for a specific user. If we had modified just the user slice, so instead of writing set property user 1000, just to remove this user ID. This could affect all the users we have in our system. We can run a program directly by setting those parameters. For this, we can use SystemD run, and now we'll pass the parameters, for example, the CPU quota, let's say 25%. And again, we'll run the stress program, or the CPU is the same, 3. Okay, we see that this is running our stress program as a service, and it actually occupies the same amount of the CPU as before. Now we can type system control stop run U204 to service, and this should stop the temporary created service, so our processor should be free. Okay, the other way was just to kill the stress process, right? It's very interesting to type those things to test them out from the console, but we have also another opportunity. We can actually create a service which will run our command, such as this one, stress, and we'll wrap it with parameters. Okay, so for this, we'll go to etc systemd system, and here, as you can see, there are a lot of services, and we are ready to create our service. Let's call it stress test. So type sudo nano stress test.service, and in this file we have to specify several sections. We'll specify description of the service, and then for the actual service, first we'll create our group and we'll set our parameters. Let's say exec start pre. So before running the service, we'll set up our group. We'll run user bin cgcreate, and we'll create CPU. Set cgroup1, and again we'll set 2 parameters right now, the same exec start pre, user bin cgset. Now we'll set the limits first for the CPUs, CPU set dot CPUs 1, so we'll run on the second core, and we'll add it to the cgroup1, and the same, but this time for the memory nodes, CPU set mems equals 0, again to the same group. We will run our service, so we will execute it. So type exec start user bin cgexec. Here we'll specify the controller of the group, CPU set cgroup1. We'll set the sticky parameter and the command we would like to run, which is user bin stress. Will occupy 3 cores. After the service has been created and someone stops the service, we would like to remove the newly created group. On exec stop post, we'll run cgdelete, and we'll specify the control group. First the controller, CPU set cgroup1. Here also we can provide additional parameters such as CPU quota and CPU shares. Let's say 50%. This is our hard limit. All right, so this for our service. We save the file, and now we can run it. So type system control start and the name of our service, stress test service. Type notification, and now we can watch again what is happening in the top. We see that the process is started and it runs specifically on the CPU 1 or the second core. So we achieved this through this file. Now if you like, we can stop the service, and we can see that the CPU is normally loaded and the stress test is no longer here. If you would like at some point to monitor what's going on inside of your service, we can type for now control -u and then typing the service name, which is a stress test service. And we see that it has been loaded and then it can be stopped. So this is very good for debugging purposes, and you can exit with Q from the journal log. All right, that's how you can control the usage of the resources. For more information, I recommend the following resources. We go to the browser, and one is on the CPU sites from kernel.org. You can see here how they work, simple examples, and what kind of parameters you can modify, and also how you can place even running tasks into already running CPU set. And the next one is CFS bandwidth control, document about the process scheduler inside of Ubuntu and Debian. Here also you can find useful explanations and examples on how you can limit your CPU usage and why the limits work in this way. The next resource is SystemD resource control. You can find really useful explanations on how you can control the I/O and the memory and how the different options impact the resources. So enjoy.